Hello and welcome to API Documentation, a part of the Building APIs with ASP.NET Core course. In this module, we'll talk about why documenting your APIs is a good idea and how to get started with Swagger. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you how to build APIs with ASP.NET Core. In this module, we're going to dive into API documentation. First, we'll discuss why this might be something you'd want to do, and then we'll walk through the process of setting up Swagger, which implements the OpenAPI specification. In this section, we're going to discuss a couple of the reasons why you'd want to consider documenting your APIs. When you build software, you're generally building against a set of predetermined interfaces. The tooling is optimized to tell you what methods are available, the types they're expecting, and even overloads of the method so you can figure out what calls you like to make. We call it IntelliSense. Ideally, if you didn't have access to formal documentation, examples, or Stack Overflow, you probably could figure out what you need to do in order to get your job done. With APIs, though, we have a new list of challenges. An API is similar to a library you'd add to your code, but it's not discoverable out of the box. And it's not like you can just type in a URL and it'll autocomplete to tell you what methods are callable and the type of data that they're expecting. But if you have a public-facing API, it is your responsibility to create solid documentation that explains what your API is able to do and how it should be accomplished. It's worth noting that this is also useful for private APIs as well, but if you're the producer and the consumer of the API, you shouldn't need to worry about this as much. And thankfully, this has already been considered. The OpenAPI specification already dictates a process for documenting your APIs in a way that can be consumed by other services. The goal is to allow both computers and humans to understand the capabilities of a service without any direct access to the implementation. For our demonstrations, we're going to discuss implementing Swagger, which can produce and read OpenAPI-based configurations. In this section, we're going to discuss adding Swagger support to our ASP.NET Core APIs. There are a couple of packages out there designed to help you add Swagger or OpenAPI functionality to your applications. And since we can't cover them all, we'll spend our time talking about Swashbuckle, as it's the most covered package in the ASP.NET Core documentation, and it's really easy to use. As with most configuration in ASP.NET Core, you'll need to add statements to the configure services and configure method of your startup.cs file. In configure services, you'll need to add a call to add SwaggerGen, and by itself, this might be enough to get you started. We'll come back to this method in a couple of minutes and discuss ways that we can add more detail. In configure, we're going to add two method calls. Use Swagger generates the Swagger endpoints, which is a JSON file. The JSON file by itself is not entirely useful. Use Swagger UI allows you to pull in that JSON file and turn it into a full-blown interactive user interface. How do we provide documentation data to Swagger though? ASP.NET Core provides several attributes that we can use to describe the behavior of our API calls. Produces response type tells Swagger the known possible response types for any given action. And since this is a getById call, there are two likely results. First, we'll return a 200 OK in an instance of the product. And Swagger is smart here. It'll look up the schema for a product and provide us with the metadata for it. And the other likely result is a 404 not found if we were given an invalid ID. In previous modules, we discussed how ASP.NET Core can filter and return data in either XML or JSON. And it turns out, if we provide that functionality, we can tell Swagger with the produces attribute. By decorating an action with produces, we can provide a list of every media type that the action could potentially respond with. When you run this example, Swagger will produce a UI for you with all the controllers and action definitions that you had. But what about all that fancy configuration we added to our actions? It shows up and it looks amazing. Here are the two response types and what someone should expect if they were to receive either a response in JSON or XML. This is a really nice feature that you get almost for free. But what if you wanted to add some more? For the longest time, C# has supported XML comments. These comments are read by tooling like Visual Studio or VS Code and can help the development experience a ton. It turns out Swagger can read these comments too and use them to make your documentation better. There are 3 steps involved for adding these features. First, you'll need to add the comments. The example here summarizes what the API endpoint is supposed to do. It provides an example request, but in reality, you can just use the remarks to explain anything you want about the call. The returns property tells users what they should expect from the call. Note, since we already defined produces response time attribute, Swagger has a full definition and schema for what a product is. And finally, we can provide data for why certain response codes would occur. If you're defining a produces response type attribute, it's a good idea to add an XML comment why. Back in the startup CS file, you'll need to tell Swagger where it can find the .xml comments once the project is built. And generally, these files are in the same directory as your executables, but you can set the location to whatever you want. The important part is that you're telling Swagger where it can find your comments. And comment files are not generated by default with ASP.NET Core applications. You'll need to enable this feature by editing your CS_proj file and setting generate documentation to true. Note, if you enable this feature and do not have XML comments in your methods, the compiler is going to throw some warnings. You can prevent warnings with the no warn for warning number 1591. And also good news, if you generate documentation files, these can also be used by libraries such as Sandcastle for developing internal documentation. And here are the comments in action after you've built and run the API. Notice how the XML comments are fed into the Swagger documentation, giving everything more readability. In previous module, we went in depth on data annotations and how we can decorate objects in our APIs to help with validation. And it turns out these same annotations are used by Swagger to help define object schemas. And this is a feature you get out of the box, no configuration required. In this demo, we're going to dive into implementing Swagger for the first time into our ASP.NET Core API. Hey everyone, we are going to add Swagger API documentation support to our API. Again, we're back in our product controller. You've probably seen this a million times. We have 3 methods on it: get products, get product by ID, and also create new product. And what we want to do is we want to add some basic API documentation to this application, so someone other than us can use the API fluently and have an understanding of what's going on underneath the scenes. And with that, we're going to use Swagger. And at the moment, we don't need to make any changes to the product controller. I've already taken the time to add the Swashbuckle package for ASP.NET Core. Swashbuckle is the middleware that implements the Swagger support for this application. Over in our startup CS file, we need to do 2 things. We have to add the injections for the Swagger dependencies. Then we also need to tell ASP.NET Core that we want to create or use a Swagger endpoint. So first things first, in services, we're going to say services, add Swagger gen. And we're not going to pass in any parameters at the moment. We'll leave this the way it is. And then down at the bottom, after use routing, I'm going to tell it app use Swagger. And this by itself is the bare minimum to create a Swagger endpoint. Let's run this and just show you what happens. I'm going to bring up a web browser, and in the web browser, we're going to point that to the Swagger definition file. This is a predetermined URL by using Swagger, and that's swagger/v1 swagger.json. If we run this, you can see we get a Swagger definition. It includes the paths to our different endpoints. So here's API/products. There's a GET request. It tells us what some of the responses are, like how the content is able to come in. There's a lot of information in this definition. And by itself, it's not meant to be human readable. It's meant to be machine readable. How can we turn this into a UI that makes sense to us and provides actual good documentation? Now back over in Startup CS, in addition to using Swagger, we're also going to use Swagger UI. And inside of Swagger, use Swagger UI, we're going to pass a reference to the Swagger endpoint. And this looks like something we've seen before, Swagger v1 swagger.json. That points to the internal reference for the Swagger definition. So going into the browser, if I instead go to swagger/index.html, this gives me a UI for the current implementation of our API. So if we scroll down, we can see there's the 3 actions on my controller: get, post, and get again. We can dive into these and see, all right, well, this one doesn't take any parameters. The post request does take parameters. What kind of parameters does it take? It takes an ID, a name, a description, and a price. Now this data can come in as either JSON or it could come in as XML, whichever we prefer. And at the moment, as far as it's concerned, it only returns a 200 OK. This is the assumption of Swagger that it's going to return a 200 OK. And then what's also interesting is down here at the bottom is the schemas. So the schemas tell us that we are dealing with a product object. And if I click on that, we can see it has the 4 properties of a product: ID, name, description, and price. In addition to that, it also tells us the limits and restrictions on those objects. Where does this information come from? In a previous module, we discussed model validation, and we talked about data annotation that you can use on different objects that allow you to control what the ranges of certain properties should be. Swagger can read these data annotations, pull them into the definition for you, and you don't have to do any additional work. Now, the documentation that we saw is not as good as it possibly could be. How can we decorate this controller a little bit more to get some more useful information out of it? One of the techniques we can do is we can tell Swagger the types of responses that will come out of any given action. Here are 2 attributes we could potentially use. The produces response type attribute tells Swagger what type of object we are expecting to return from this action. In our case, it's going to be an IEnumerable or a list of products. And when that happens, it'll be on a 200 OK status result. Additionally, because we've set up this application to accept and return both JSON and XML, we can tell the action that it produces JSON or XML. Swagger will pull all this in for us. Let's take a moment and decorate the other 2 actions. Here again, we're using produces response type, and we're returning a type of product, and that's going to be on a 200 OK. But there's also a case where a person might type in an ID that doesn't exist in our database, and we would return the subsequent 404 not found. So we'll tell Swagger that we can produce a 404 in certain cases. For create new product, we'll return a 201, not a 200. We want to ensure that we're creating a new product. And then we can also produce a 400, a bad request. And that's in the case of model validation failing on the post. So how does this look to Swagger if we run the application now? So I have refreshed the application, and I'm going to come down and click on the post request. And we can see it kind of looks the same that it did before. But if I scroll down, instead of a 200 status result, it now shows us the 201 and the 400s for this post. And it gives us examples of what the response types look like. Another nifty little feature I like of Swagger is this ability to try it out in the UI. So if I press try it out, it will give me a sample request body, and I can type in some metadata and hit execute. And what Swagger UI will do is it will execute that request against my local API, tell me what it did, and then it will return the response. So I got, in this case, a 201 created back with an ID of 2. And what were those response headers? But is there a way that we can add even more information to our documentation? Absolutely, and that is done through XML comments. Now, you probably have used XML comments before in C# or ASP.NET Core applications. It's been in Visual Studio forever, but this is an actual useful implementation of it. So I'm going to add an XML comment for Get Products that provides a little bit of metadata for the request. First, we have a summary of what this particular endpoint does. I can provide some remarks about the endpoint. Now this, in my case, is just a sample request. What would you call the get here? But you can put in as much detail as you want, and this will get pulled into the final product. Finally, you have returns and then response. For returns, you're telling the user in plain English, what are they going to get back by calling this endpoint? And then the response, you should have one for every response code. At a minimum, every response code that you have a produces response type attribute for. And give a plain English description of what the user is going to get back. Well, let's do the same thing for the other two actions. One quick note on Get Product by ID. Notice I added a response for a 404. So the person knows why they would get a 404. And then on Create New Product, again, we have a sample request that gives a little bit of information about what we're expecting. And we're including the response for a 400. That just tells us the product had invalid data. Now, there are two more steps involved in order to get the XML content into our Swagger UI. The first one being in our CS proj, we have to enable the generate documentation file for this application. That isn't in there by default, and it's at the false by default. So we need to make sure that we turn that on. The second thing that you might want to do is if you have generate documentation file enabled, you will get warnings for any methods that don't have XML comments. And that's not something that you necessarily would want, because there will most likely be a lot of methods that don't have XML comments with them. So what we'll do is we'll turn on no warn for 1591. That's the warning number for XML comments. When you have this option enabled, if you build your app inside of your bin folder, this generates an XML file for this particular application. So if we look at that, here's all the XML documentation for our app pulled into one place. The next thing that we have to do is we have to tell Swagger to use that XML comment file. That takes us back to Startup CS. And inside of Swagger Gen, we're going to add a Lambda for configuration. And we're going to write some code that tells Swagger where to find that XML file. The first two lines just set up the path for the XML file that points to the local debug folder. And then we call a method in Swagger Gen to include XML comments, giving it that path. Swagger will process that file and add it to our documentation. Let's take one final look. And on the refresh, we can see all of our metadata has pulled in successfully. Our GET requests, our POST requests, and our other GET requests all have summaries about what those options do. If I open one of the items up, we can see I have my sample request. And when I scroll down to responses, it gives the description of what the response codes are for. The same thing with POST. I have my sample request showing me what to expect. And as I scroll down, I have information about the response types. In review, we've discussed why you would want to document your APIs. And it simply comes down to that most APIs are not discoverable unless you have direct access to the API source material. Documentation provides a glimpse into what is possible without the guesswork. Then we discussed implementing Swagger into your APIs so we can quickly and easily build good documentation. Thanks for listening to the API documentation module, part of Building APIs with ASP.NET Core course. My name is Kevin Griffin.